Okay, you're ready to go.
All right. Good afternoon, good morning, or whatever is the time in each of the places. Thank you so very much, Bruce, for inviting me to present this delayed delivery. I couldn't make it to the symposium because of the hurricane that was affecting Florida at the time. Very brief, I would like to put some experience, ideas, and data that we have accumulated through the years on the issue of the value of CPUE from sport fisheries and from tournaments that could help develop some idea on how to assess the billfish stocks in the region, in the Central American region. This region is complex from an oceanographic standpoint, and it makes very difficult to patch and put together several sets of data that were not developed, not collected for the purpose of stock assessment. And the issue then regarding billfish management in the EPO is that not enough knowledge exists that could result in credible stock assessment with acceptable levels of accuracy and precision. So in this presentation today, I would like to provide some insights on the sport fish, billfish CPUE that is coming out of highly stratified marine ecosystems. So very briefly, the habitat compression that most of you know in this area is simply spectacular. And the problem then is that we have some limit in terms of the habitat. You have an arrow for Central America there, and the habitat truly is within the upper 50 to 60 meters from the surface. And obviously, there is an accumulation of biomass in there, and there are several different niches in terms of the general ecology and biology of the species in the region. Productivity is very significantly affected seasonally by those winds that are coming through low passes in the Oaxaca region, as well as in the Costa Rica, Nicaragua region, as well as in the Gulf of Panama. Those winds are highly seasonal, as I said, and they create significantly different sea surface temperature stratifications in the region. Some of them, like the Costa Rican dome in the middle of the figure there, is semi-permanent, while this is very significantly seasonal. It disappears completely in some month of the year, as we will see. And then we have the area of the Panama Canal, and most of the data we have is coming from Tropic Star Lodge, where this particular star is located. So here we have horizontal and vertical stratifications that are seasonally changing, and to measure all these things are just about impossible with the level of research investment in the area. And then on top of everything, in every of these passages, we have these two conditions, the anticyclonic creating downwelling and the cyclonic creating upwelling in these places. And therefore, we should expect conditions to differ in this area than in these areas. And obviously, most of the commercial catches that are realized from this area are obviously affected by different catchabilities related to the concentration of density of fish in these areas, which are so dissimilar. So the first presentation is exclusively on the sailfish in Guatemala. It's important to realize that the data on catch per unit of effort as an index of relative abundance is in this area here, coincides very well with the distribution of the satellite tracks that we have from animals that we have tagged throughout the region. And obviously the distribution, the red distribution, matches very well the habitat, compressed habitat of the region. So the situation here is that billfish, especially sailfish, prefer this area for some reason, and that for some reason should be underlined. You will see throughout the presentation that this animal will prefer certain areas at certain times of the year when there are some prey species available, and they are able to come across very significant oceanographic barriers, and it doesn't seem to be a problem for them to do that, and they do that in search of food. First of all, some of the sport data for Guatemala, the one in red up above there, and then the one in Costa Rica that is coming from a fishing club in the country. These are the longest existing databases that we have. And we notice that in Guatemala, this is an increasing trend, when in Costa Rica, it's slightly decreasing. So in order to analyze this, we just fitted a very simple model there to see what and how similar are these trends in both countries. And these again are for the sport fisheries, very close to shore, within 50 miles. And for this purpose, then, we compare through cross correlations the Costa Rican and the Guatemala fitted functions, and they are very highly correlated. The meaning of this, then, is that these trends are probably being originated by similar phenomena, let us call it. And of all the environmental variables that we try to fit around these cycles, none of them truly created a very significant trend, except the multivariate ENSO index. And those extreme strong ENSO years are departing from the trend, but in general, the MEI is generally following the trends that we see in black there. The meaning of this is then that probably within the very close to shore situation of the sport fisheries, they have the presence and migrations in and out of the area. Many years ago, we put out a paper where there was some sort of a correlation between the CPUE of the sport fisheries in Guatemala and Costa Rica and the high seas CPUEs from the Japanese fleet, and they were negatively correlated. Unfortunately, the database for the Japanese fleet operations is no longer available to us, at least. They do not cover the same areas as before, etc. So it became an index that is not truly important in the use of, or for the purpose of, stock assessment. Now, coming back to the sketch here on the nature of what happens offshore when you have these wind gaps, and the Costa Rican current is very important here. It circulates in this direction, becoming the North Equatorial Current, but is deflected by the effect of the seasonal winds in this area. And in terms of our data, this is the Persane data coming from the years 2000 to 2014. They create exactly these two positions that are supposed to be, theoretically speaking, a downwelling area here. This is a major tuna fishing ground, and it's a downwelling area, as opposed to a dispersion of the animals in this area due to the upwelling, and then the area offshore that is due to a compression of the habitat in that particular region. When we analyze the situation of this group here, this is the sailfish of Guatemala that is of importance to the talk here, is represented by the figure in red there. It follows very similarly to the Tehuano winds events. These Tehuano winds events are more or less in a cyclic pattern that is very similar, but also some of the characteristics of these winds are emulating the changes in the catch per unit of effort in the sport fisheries. The catch per unit of effort here is in the numbers of fish that were raised per day fishing. So these are probably one of the highest numbers in the world for any sport fisheries. The question here, obviously, is very nice to see these type of trends when you have some data. Unfortunately, there is some lack of or big gaps in the statistical data for some cases. The question is, why is this happening? The problem then became on how to try to realize by averaging all this data by month and then compare this with the wind gaps and the speeds that we have. We see that during the windy season, you have the greatest catch per unit of effort, and as the winds dissipate, the catch per unit of effort goes down. So there is obviously in this very colorful, nice picture, some issue with catchability. And just by pure luck, we found some research that the Norwegians did several years ago in the region with hydroacoustics. And during the time of high winds, we realized then, and we observed that there is an accumulation of all the small pelagic biomass that moves into this direction here. They are stratified towards the east of the area of study. The Costa Rican dome is in somewhere here, semi-permanent, which is a barrier for the small pelagics to migrate in this direction. So there is an accumulation of biomass outside of the Guatemalan coast. And when we have the restructuring of the Costa Rican current, we don't have the stratification by temperatures, and we notice that immediately the pelagic biomass expands homogeneously, dispersed along the coast from southern Mexico all the way to Guatemala. So this obviously has to do then the movements that we observed in the CPUEs of the sport fisheries, that in this area here, well, these are the 5 main, let us say, center for sport fishing, for sailfish in this region. This is a habitat compressed area, and due to the low level of DO2. And for our purpose in this area, we notice in the work that we did with Bruce in this region that there is some sort of an expanded habitat here that is limited to the offshore by this highly compressed habitat. And unfortunately, don't see here, but here is the Costa Rican dome that is another barrier for this direction. Let me say right now that the sailfish that we tagged with satellite tags were able to cross all this highly compressed habitat with no problem, even if the dissolved oxygen was very low and in very shallow water. And there is only one behavioral aspect which is of interest. They swim across these areas very quickly in just one single direction. And as soon as they go across these habitats, they start meandering and like searching for food. And this then is some sort of an ecological trap that is semi-permanent in this region. And the movement then of the fish is like this. And this is the availability of sailfish to the fishing area, sport fishing area that operates in this range. And if we look at this, we collected some dissolved oxygen data, basically for parameters of salinity, dissolved oxygen, temperature, etc., to see how this is by depth. And this is for the 20-meter depth. And obviously, we found a correlation between the high oxygen areas with the most concentrated small pelagic schools. And based on that, we then plotted the georeferenced catch statistics from the sport fisheries in Guatemala, and they coincide almost exactly how these oceanographic conditions were prevailing while these animals were accumulated in this area. In our surveys in this region, we found that there is quite a bit of biomass here, lots of tunas and lots of billfish, and there is no sport fisheries in this area because there is no natural ports where to keep the vessels, and it's impossible to go from this port here, the only port in the country, all the way over there in daily trips. So there is a difficulty there, and that's the reason why we don't see this type of activity in this area. These canyons, there is one canyon there and one canyon there, play a major role in terms of the mixing of nutrients, etc., that probably are very fundamental to the accumulation of these pelagic fishes in that area. Now, the problem of habitat compression, we release some animals in Costa Rica, and they start moving all the way north there. And here you have the depth of the mixed layer, and they try to stay in an area between 30 and 40 meters, and they never ventured in very deep water, let us say the 60-meter depth of the mixed layer. That condition then translated to data that is related to the tournaments in Guatemala, the presidential challenge that ended in 2013, and the data, obviously, with compression in terms of the average mixed layer depth, gave us a very nice fit, if you wish, on a negative correlation. The more compressed you are, the higher the catchability. So here we have two issues, statistical issues with the catch per unit of effort. One is the spatial concentration that adds values to the catchability through this environmental trap. And then you have the effects of the habitat compression due to the average mixed layer depth. These two situations are very difficult to clear in any effort to standardize catch per unit of effort, and in terms of using the sport fisheries catch per unit of effort in stock assessment for the whole stock. So this area here appears to be some sort of a unique in terms of the seasonal ecological trap of Guatemala, that the ecological traps end up being or generating an hyperstability of seasonal sailfish catch rates. And therefore, that's the reason why in Guatemala, we see in the last 30 years, extremely high catch rates with no effects of apparent exploitation, commercial exploitation of the stock. The increased seasonal vulnerability of the sailfish in this area is of concern. There are efforts to develop some coastal artisanal fisheries in this area, and obviously how easy is to catch a fish there, obviously will bring some sort of a potential depletion if no regulations are considered for this species. So the CPUE, and it's sort of a conclusion, the CPUE for the Guatemalan sailfish area is statistically strong as a local index of relative abundance, and obviously, as it is now, it should not be used for any purpose of assessing the sailfish population in the Eastern Pacific. But we need to find some way on how to extrapolate this knowledge into the conditions of the physics that changes so dramatically among the different areas of the region. So that is basically the end of the first publication. That is Bruce there fishing when we were tagging these animals in the region. And the next presentation is related to black marlin and sailfish. And here the co-author is Alexis Peña from Ehrhardt in Panama. We have some maps on or related to the distribution of sailfish and of black marlin in the region. All of them are found at the edge of the continental shelf there. And there are very significant differences on what is going on in this area here from this area where they disperse to the sea in different ways, let us say. And based on this distribution, we concentrated our research in the difficulty and complexity of the winds in the region, in the Gulf of Panama specifically, in the sense that you have persistent winds from the north, from basically December to March, April, and then it changes to south, etc., with a peak in October. But these changes in winds are so significant that the geostrophic circulation in this area changed dramatically from anticyclonic and cyclonic, both of them creating downwelling and upwelling conditions, to an anticyclonic downwelling condition when it's blowing from the south. So the situation here is very peculiar in the sense that those changes create along the coast some significant differences in the mean sea level that we have here. What is in red is what is happening in this region here, as you have this seasonality in the differences in wind. Let us remember that in Panama probably is the area in Central America where you have the most spectacular intertidals, let us say, and the changes in the sea level. When we compare, all right, when we compare the distribution of the small pelagic biomass estimated from hydroacoustics in these two time periods, January, March, we see, for example, that the upwelling that brings a lot of low dissolved oxygen to the surface, there is nothing in terms of the effect of this upwelling in this area here. However, in the results of the analysis, we have data that shows that there is a very significant amount of biomass that is of squids in this region. The changes dramatically here when the winds are coming from the south, that is from July to September geostrophic circulation, where all this area here is expanded to sardines and thread herring and anchovies. And this is the time of the year when the Panamanian fishing industry, for example, carry out the fish meal industry, start operating for 4 or 5 months of the year. There is a dramatic difference between the species composition and the abundance of the species in these two regions. And that dramatic difference obviously is observed in terms of the catch that is being obtained from tropic star lodge in the extreme eastern part of the country, where sailfish and black marlin are important when the sea level is low and when you have the presence of animals like the squids in the region. Once we had this data, we start looking at the issue of black marlin going down in terms of the productivity for the region, accepting some big values there. And we fitted very many different environmental variables to this database. And a cross-correlation again between this information and a 3-year average of the North Equatorial Current gave us a very high cross-correlation when we delay this information, the oceanographic information, between 10 and 12 years. The meaning of this then is that the animals caught, if there is an important correlation between them, and this is really spectacular in the sense that you can see here, for example, the red, what is in red here is the north equatorial current, delayed, in this case, 11 years, and the productivity of the black marlin out of the corner there where you saw where these the squids were located. This is very unique. Obviously, it's a simple correlation. We don't have any explanation for it except to say that this should be some sort of an indication of an index that is related possibly to recruitment. It is a coincidence that the animals in the easternmost areas of the Eastern Pacific related to black marlin are very large animals. All the world records were coming from these regions, and they're still coming some very large animals. So probably this range of ages is coincident with the potential age structure of these animals in the region. Unfortunately, we will never have the biological data to understand age structures in this region. There is no way to collect that data at this moment. There is no historic data either that could give us an idea if indeed this is a group of very old black marlin. The only thing we know is that they are very big, and this statistical correlation is just a statistical correlation that just by coincidence otherwise is really spectacular in terms of the coincidence on the trends. Again, we standardized the data on the NEC and the black marlin data, and we fitted some simple linear regressions there, and then we compared the regressions with some covariance analysis, and they were not significantly different. And again, it is surprising to see such a good fit, but again, correlations are correlations. We can fit weather conditions in Miami and how much coffee is being drunk in Paris, and probably there is a very high correlation too. So spurious correlations, we need to treat them with care, but this is an important clue, at least, that we should explore a little bit more in terms of how to integrate some of the physics of the ocean here with some of the signals on the species along the coast that could be very different. Very quickly now, if we look at the case of the sailfish in Panama, we have a condition where you have an increase in the amount of fishing effort from the number of long line licenses from Panama in this region. There is a lack of information in this area. But the number of individuals that were obtained in Tropic Star Lodge dropped significantly after this year here. As this effort increased, this number came down. So the suspicion is that probably this is an effect of local exploitation on the local availability. In searching for this situation, we compare the Incopesca data for the industry in Costa Rica, and it follows exactly the same trend. And this was extremely surprising and good to see, because that is clearly an idea that we are talking about the same sort of depletion of sailfish in this region. We obtained data with the permission of Panama, and we obtained these plots of the long lining operations. What we are talking about, this red trend, is out of these operations in this area. However, the fleets are operating intensively off the EEZ of Costa Rica and El Salvador, Nicaragua and El Salvador, and also to the west of the Galapagos Island, while the fleets from Costa Rica, the long lining fleets of Costa Rica have been operating very close to shore, creating obviously a depletion in that particular region. So what we have here, please realize that the catch from sport fisheries that we are dealing with is coming from this point here. So probably this is an effect of the depletion of the entire stock in this area that is not being truly reflected in the catch per unit of effort of the sport fisheries very close to shore. Once again, there might be some sort of another ecological trap here where the industrial fisheries are not operating, that is creating the opportunity for those particular sport fisheries to be still operative. In terms of the different indices that we could use to just try to find out what is going on with this trend in the productivity of sailfish in Panama, we found that there is a very strong correlation, not of the NEC, but of the NECC, the countercurrent. And it went very well until it depleted. This depletion here is not following the sign of the oceanographic data. And that again is another food for thoughts, let us say, in terms of what is going on. There is a 7-year delay cross-correlation found in this little bit of data that is here. Unfortunately, we don't have data prior to 2003, in spite of the fact that this is a sport fisheries that was initiated in the 1960s. Some work done here at the University of Miami, Mark Fitchett here estimated the possible age structure of the entire stock, and he was able to find some sort of a correlation between age 5 fish and the NECC. That is just to give support that probably we need to remember that one of the record trophy size of sailfish is from this area. So these are supposed to be the older individuals that we have from this group here, coming from very young to older fish. So this is an interesting possibility of the migrations, etc. So the last message here is a seasonal availability of black marlin and sailfish. It's always occurring during periods of increased seasonal coastal habitat compressed conditions, and the decreasing trends in sport black marlin catch, possibly due to environmental effects impacting recruitment. And obviously that is just a speculation that needs to be further revised. Here, what is important is to find out where is that black marlin spawning in this region. There are some efforts. Guy Harvey is trying to has tagged quite a few black marlin in the area, and there are some movements in there from inshore to offshore that has been published in several publications by Dr. Logan. And it will be interesting to find, in the same way that in Australia, they have a very clear idea on what is going on with the spawning of these animals. Evidently, it's difficult at this moment to think that they carry out a transoceanic migration on a seasonal basis because of distances, etc. And probably then this may or may not be a feeding area, as has been suggested in the past. So there is a wide space for research here. Once again, the main problem is obviously the lack of information. The significant drop in sailfish catches is identified with very high level of tuna and mahi long-line fishing intensity in the area. Intensity meaning the amount of fishing effort per unit of areas. And obviously, is an effort that is The objective is tunas and mahi, but these billfishes are caught incidentally in those fisheries. So that's what I have today for the presentation as a food for thoughts. And we are obviously very grateful to Tim Choate. He was absolutely fundamentally important in providing the funding to develop all these almost 20 years of research in the region. Guy Harvey, that has been supporting some of this work, and obviously to Tropic Star Lodge, Pacific Fins, and Casa Vieja, which are major contributing to the entire database that they have. We have helped them to develop their databases, so we have important georeferenced catch and effort information on the sport fisheries.
Great. Well, thank you so much, Nelson. We appreciate it. I can't hear claps on the. There you go.
One clapping here. That's fine.
Oh yeah, thank you so much. We appreciate it. I know we all wanted to have you at the symposium, but things get in the way sometimes. But what we'd like to do now is open it up to questions. If there's a way for you to signal who has a question, feel free to do that, or you can just jump right in and we can call it. See, Julian raised his hand. So Julian, if you want to ask your question now, hopefully we will be able to hear it.
Yeah, so can you hear me?
We can hear you, yep.
Okay, great. Terrific talks, Nelson. Thanks for giving those today.
By the way,
just questions about your levels of your measures of CPUE in Guatemala and Costa Rica. I think one of the graphs had raised per trip, numbers of fish raised per trip. Is that your basic CPUE, or we found that raised was sometimes a little bit inaccurate because different captains had different ways of interpreting what a raised fish was, whereas we tended to concentrate on fish that were actually brought to the boat and released or captured. And in Panama, your graph showed just numbers of black marlin and numbers of sailfish caught, but no effort. But you said that you did have effort data from Panama. So could you clarify that?
Yeah, thank you for the questions. First of all, the case of raised fish against fish caught and released, we have several thousand records of these statistics, and they are extremely highly correlated. And by extremely highly correlated, I mean some 0.8 or above. And is a very unique ability of the captains. Is a very tight correlation, let us say, in between the two variables. We obviously understood that the case of estimating by eye how many animals you raised had some sort of the possibility for error, obviously. However, very many different captains released their data to us, and when we put all of this together, it's very surprising to see how similar are the estimates. Roughly between 47 to 51 or 52% of those animals that are raised are being caught. And we develop an idea on what catchability is based on this data. We thought that probably the number of animals that are raised during a fishing trip is a better estimate of the actual abundance, local abundance of the stock. And in that sense, we believe that in one day, obviously there is a possibility that you see an animal twice, but given all what you experience in Guatemala in terms of schools of tunas and a lot of billfish moving around, yes, the possibility exists that you count twice or more. But however, the consistency of the linear regressions in between the two variables gave us the confidence, let us say, that probably a better estimate of the catch per unit of effort should be related to a better idea of the abundance will be the animals raised. But obviously, the catch per unit of effort, those catch and release, are such a high number of them per day. When there is a record of over 120 fish caught in one day, you realize then immediately that either of these units are equally good for the purpose of assessing the stocks. Your question about Panama. The problem with the database in Panama is that they only record those trips that they have catch, and they do not record those that didn't catch anything. And therefore, there is no way that you can restructure that data historically. It's very difficult. We do have numbers of trips, but we don't have the catch assigned to each of the boats that carry out the trips. So in order to deal with this data, we prefer to use the sort of the cumulative of the catches in all the trips with catch in the area. And this fleet is a very stable fleet of about 14, 16 vessels that have operated for a very, very long time in the area. Obviously, there are visitors that increase the fleet size, but we need to realize that Tropic Star Lodge is a very isolated place in the Darien Peninsula that you can reach only by air. And the type of operations there in terms of the numbers of trips realized throughout the years is roughly the same seasonally. So that gave us a fairly good confidence that the total catch, cumulative catch through the years or through the year, it could be a good estimate of what is going on in terms of the productivity of the fleets. I don't know if that answers your questions.
Very comprehensively, thank you.
We have any other questions? If you don't know how to raise your hand, you can just unmute yourself and ask the question.
I have a question.
Yeah.
So I guess one of the takeaways that I saw from the talk is that the recreational catch data is plagued by hyperstability, so it's not really a good index of an abundance for stock assessment purposes. What's needed in the case of sailfish to actually begin to develop some type of realistic stock assessment?
That is a very good question, and obviously that opens discussions, hopefully regionally, hopefully for the entire Eastern Pacific. I think that it will be fantastic if physical oceanographers will join and for us to provide conditions locally. That is to mean if we can, for example, carry out analysis for Mexico, for Guatemala, as we did, for Costa Rica, that someone could do that, and for Panama and Ecuador. Ecuador is very important. Unfortunately, the latest meetings we had only last week, data from Ecuador is zero. They are not collecting any information on this, and it's becoming a real issue. And unfortunately, the sport fisheries in the Galapagos Island are not part of their obligation to collect the statistics. So, but in general, to answer your question, if we could make an interpretation of localized conditions of CPUE, probably we could be able to build up localized units of stocks of billfish that are being affected or are being attracted by local feeding conditions. And those feeding conditions are quite a bit of data regarding to the environment and what species are the ones that are seasonally present in the different porcine fisheries for small pelagics, for example. Mexico has a very extensive coastline, and the presence of sardines and thread herring from the border with Guatemala all the way to the upper Gulf of California, for example, could provide the information. The information exists as to compile different localized conditions and how we can build up then towards a unified idea of localized unit of stocks regarding the entire population for the Eastern Pacific. So the big problem here are the new events that are happening in the Eastern Pacific since the Korean, Japanese, and Taiwanese fleets kind of move out of the area starting in 2000. There was a very significant decrease in the amount of effort, and the catch per unit of effort in some areas disappeared because of lack of operation in those areas. So we have gaps in the database now, spatially speaking. But however, the main concern now is the operations of the Chinese in the region. And the Chinese longlining are transferring product at sea, as you know, and in Panama, obviously, are fully aware of this transfer, etc. And the problem then becomes difficult when you have a country that is not reporting the sailfish or any big fish that they are catching. So I think here what is needed to understand is how significant and how dynamic these localized coastal systems are. And each one is very well characterized by their own definitions of the driving variables that are connecting, integrating the prey to these feeding species, let us call it, top predators that are moving around, collecting the best amount of energy they can in the different areas.
Thank you.